One of the powerful new features of 3ds Max 7 is the new normal mapping pipeline. For those of you who are not familiar with what normal maps are for all intents and purposes a high-resolution, higher-order bump map. They were originally developed for the gaming industry to allow for real-time game models to look much higher resolution. To give you an example of what that might look like, here is what's called a tangent-space normal map. So what a normal map does is it uses luminance information just like a bump map to define height. So the brightness of the pixels defines how high off of the polygon that pixel is rendered. But then it uses color information to actually define what angle it is. This way, when lighting falls across that surface, it can actually be calculated much more correctly because it has more data than just height. It also knows the normal angle. So that's a tangent space normal map. And here you can see a local space normal map where the colors are actually based in the local space of the geometry it's on. So based on that, what we're going to do is go in here and take this high resolution model of a statue and make the low resolution model look just like it. If you look at the models themselves, you can see that my high resolution version is pretty substantial. It's about 64,000 polygons, whereas the low resolution is only 4,000 polygons, and we want to make them look absolutely identical. In order to do this, what we're going to do is take the low resolution version of the statue. We're just going to slide it over underneath the high res version, say right about there. And then I'm just going to move it over and I'm going to open up the new render to texture dialog, which now includes the normal mapping system. What render to texture will allow me to do is project the normal data of the high res model onto the low res. So in this case, after doing that, it's created a projection modifier on my low res model. And what the projection modifier does is create a cage within which it looks for geometry to pull high-res data from. So in this case, you can actually see here the cage perfectly wraps around the geometry, and this is a default. I can then go in and hand model this cage to account for any irregularities or extra geometry I want to deal with. Also note that I can project from more than just one high-res object. I could have a character or a scene or an environment made out of hundreds of objects and use those all as a projection to project onto one single low-res version. Now in this case, I've got projection all set up. I can go in and I can just set the options. I'm actually going to do this in a local space since it's a statue and isn't intended to deform. So in the local space that's set, I can now bop back out. I've got it set to render a normal map at a 512 resolution. I can of course add extra versions of the maps, complete maps, specular maps, maybe even a height map. In this case we'll just stick with normals. I've got it set to save into the bump slot, and I'm going to have it output into a normal bump. Now, normal bump is a type of material type which allows us to actually render normals. So the normal bump will allow us to display the normals in the viewport, but it'll also let us render them in the scanline renderer or in mental ray. What this means is that use of normals is no longer limited to just games. I can actually use that same normal information for an architectural walkthrough or for background characters in a crowd scene of a film. Anywhere I want to reduce the amount of polygonal detail and polygonal geometry and just use memory to store a few simple maps. Now in this case everything's set, so I can just go through now and hit render, and it'll start rendering through that particular image. Now you'll see I've got very simple mapping on this geometry. The reason for this is I just wanted to do this very quickly and show you how easy it is to do without having to set up complex mapping coordinates. So in this case there's not much to this character's mapping. I just did a complete unwrap with the UVW unwrap modifier. So now that that's set off, I can pop back out of here. And again, I'm just going to move the low-resolution geometry over and turn the cage off. Go into my material editor. Let's just pull up the material that's on this geometry and take a look at it. So you can see here I've got a normal bump, and I can go into the normal bump slot. And let's just take a look at what that image looks like. So again, there's the normal information for the statue. If I back out, I want to display this in the viewport at this point, so we're going to use the DirectX display of standard material, turn that on. And then I'm going to turn on the show in viewport. So in this case it's a slightly darker version because I'm not using I didn't create a diffuse map for this character, but you can actually see that all the detail for all the wrinkles in the gown is all there. And if I just pull out a little bit, let's just close those windows, I can actually grab onto this light and move it around so you can actually see the effect in the viewport of different angles. There we go. And because it's got the normal bump in it, I can hit render and actually see that rendered in the viewport as well. And you can see that they look very much like the exact same models. As a last example of normal mapping, here I've got a hand which was modeled by John Chalfant. And what you can see here is that I've got two versions. One of them is the high res and one of them is the low res. If I go to a wireframe mode, you can actually see the high res is quite high and the low res is a very simple piece of geometry. We've already projected the normal mapping onto this version, and just to give you an idea of the total size difference, let me just pull up my polygon counter. And you can actually see here, this one is built at a 29,840 tries, whereas this version over here has only got 949 tries. So it's a much lower res version of this same geometry. Now what I can do is just take that off, grab my light, and you can see again that I get the correct shadow and highlight adjustments as I move it around. And of course, as I said before, because we're using normal bump, we can render this to the scanline or mental ray, so you can use the same technology in more than just games, but also in design visualization or film broadcast. And there you go, there's all your high-res detail locked into the model through a map.